Welcome to Alphanumerictricks. Today we are going to see next problem 6 in Lagrange's linear equations. This is very important problem, and problem set 17 in partial differential equations. Now we will see how to solve this problem. X squared minus yz into p plus y squared minus zx into q is equal to z squared minus xy. Solve this problem. So you have to write the given form of the problem. This is capital P into small p is there, capital Q into small q, and this is R is there. So this is of the form Pp plus Qq is equal to R. This is Lagrange's form that you have to mention in your problem. After that, you have to write the values of P, Q and R. Okay, P is equal to x squared minus yz, and Q is equal to y squared minus zx, and R is equal to z squared minus xy. After that, you have to find out the subsidiary equations or auxiliary equations. What is that? Dx by P is equal to dy by Q is equal to dz by R, and you have to substitute the values of P, Q and R here, okay, in this subsidiary equation. So in that case, you have dx by P value is x squared minus yz is equal to dy by Q value is y squared minus zx is equal to z by R value is dz by z squared minus xy. So now we have to take this equation as number 1. And here grouping is not at all possible. When you take comparing these two terms, no term get cancelled. Here also no term get cancelled, and when you comparing first and last also no term get cancelled. So in such cases, what we had to do, we had to proceed in the another way. Okay, some other way also we can proceed. I'll show you how to get the answer for this type of problem. Okay, and multipliers also, when you're using method of multipliers, directly we can't use the multipliers here. Okay, so we will check how to do that. Each ratio will be equal to, you have to subtract this term, first two terms, dx minus dy by, this term you have to do it, x squared minus yz minus y squared minus zx is equal to, that is we are taking this each ratio will be equated to subtract two terms and then write first and 2, 2 and 3 and 3 and 1. Okay, so or 1 minus 3, that way you can do it. Next one is, this will be equal to dy minus dz by y squared minus zx minus of z squared minus xy, that will be equal to dz minus dx, or you can do it dx minus dz divided by x squared minus yz minus of z squared minus xy. After that, you have to simplify this term. Okay, so we will be equal to, that is having dx minus dy divided by, here x squared minus y squared minus yz minus it becomes plus zx is equal to dy minus dz by y squared minus z squared minus zx, this minus it becomes plus xy. That will be equal to dx minus dz divided by x squared minus z squared, that minus yz, and here minus it becomes plus xy. Okay, after that you have to combine the terms, square terms, so you have to combine together. Okay, and common terms you have to take it outside. So dx minus dy divided by, here you can square these two terms, and these two terms is it is common, so take it outside. So x squared minus y squared plus z you can take outside. When you're taking plus z, here first this term becomes plus and this becomes minus, so here you have to take plus term first and minus term second, is equal to dy minus dz divided by, here you have to combine these two terms, y square minus z square, and plus here which is common, x is occur both the terms, and you take plus x, that will be easy. Okay, so plus x you have to take outside, and here y term is plus, so first you write, and here z term is having minus, so minus z, that will be equal to dx minus dz divided by, here x squared minus z squared you combine, and here which is common, y is common, so take plus y outside, and remaining term you have x minus z. Okay, and from that, which is next we have to take this is our equation, dx minus dy by this term. So from that we have to simplify further. You can replace this x squared minus y squared as a plus b formula, a squared minus b squared formula, a plus b into a minus b, x plus y into x minus y plus z into this x minus y. This will be equal to dy minus dz by this y squared minus z squared can be written as y plus z into y minus z plus this x into y minus z. That will be equal to dx minus dz by this term x squared minus z squared can be written as x plus z into x minus z plus y into x minus z. That is this term formula you are writing, x plus z into x minus z formula. Okay. After that, here which is common in this term, here x minus y is common. After writing this, from this ratio x minus y is common, and here y minus z is common, and here x minus z is common. So take outside. So dx minus dy by x minus y is taken outside. Remaining you have x plus y plus z is equal to dy minus dz by y plus z is common. Sorry, y minus z is common. Take it outside. Y plus z plus x. And next term dx minus dz divided by x minus z is common. Take it outside. X plus y z plus y. Okay. So look at this. X plus y plus z is having both the terms and all are ratios. So you can cancel these terms. Okay, so after that you have dx minus dy divided by x minus y is equal to dy minus dz by y minus z is equal to dz minus dx by x minus z. Okay, you have to do this problem in a different way. That's why this problem is very, very important. And then number this as ratios 1, 2 and 3. Now we have to group the ratios. Okay, so grouping the ratios 1 and 2. Okay, first we have to group the ratios 1 and 2. dx minus dy by x minus y is equal to dy minus dz by y minus z. When you are integrating here, what is integration of differentiation of x minus y? Dx minus dy. This can be written as d of x minus y, isn't it? So you can write this to be d of x minus y divided by x minus y, which is equal to d of y minus z divided by y minus z. When you integrating this, you get the term x log. Okay, when you differentiating the numerator, you get when you differentiating the denominator, you get the numerator. Then that term can be written as log of denominator. That's why dx by x is log x. When you differentiate denominator, differentiation of x is 1. 1 into 1, when you get the numerator is 1, isn't it? That's why this term can be written as log x. Okay, so in the same way, you can write this one integrate. So for that, grouping 1 and 2, we have d of x minus y by x minus y. So when you integrating this, integration of this term. So integration of x minus, differentiation of, what is differentiation of x minus y? Dx minus dy. That when you differentiating denominator, you get the numerator. That's why this can be written as log of the denominator. That is our integration formula, isn't it? So which is equal to log of this dy, this term dy minus dz by y minus z is log of y minus z plus constant of integration. You are using log. Okay, log a. So in the same way, you have to take this log to other side. Log x minus y minus log y minus z is equal to log a, or you have log a minus b is log a by b. So log x minus y by y minus z is equal to log a, or you have y minus is x minus y by y minus z is equal to a. This is our one independent solution. Okay. And next we have to find out the another independent solution. For suppose when you for another independent solution, we have to take this term. Okay. First term is your y minus x minus, when you taking the grouping 1 and 2, grouping 1 and 2, you get x minus y by y minus z, isn't it? Suppose we are grouping 2 and 3. Okay, suppose we are grouping 2 and 3. What will be the solution? Similar to this, you can, when you grouping 1 and 2, x minus y by y minus z is equal to a is a solution, isn't it? When you grouping 2 and 3, what will be your solution? Your solution will be y minus z by x minus z. That is your b, isn't it? When you're grouping 2 and 3. Okay, so without writing the terms, you can write it, because we get the similar to this one only we have now. That's why. Okay, so and you get your Lagrange's general solution is you have to get the two independent solution. What is independent solution? There is no relationship between these two solutions. Okay, there is no relationship between these two solutions. But look at this solution, yx minus y by y minus z. Here y minus z is present, divided by x minus z is there. We will check the relationship between these two. Suppose we find it 1 plus a. What about 1 plus a? 1 plus x minus y by y minus z. What about this term? Y minus z plus x minus y divided by y minus z. Okay, and here plus y minus y get cancelled. What about the remaining term? You have x minus z by y minus z. What about this term? X minus y by x minus z by y minus z. X minus y by y minus z. This is our solution A, isn't it? Solution x minus z by y minus z. X minus z by y minus z. Sorry, x minus z by y minus z. This is our B, not A. This is our B. B is A. Y minus z by x minus z, which is equal to reciprocal of B. Isn't it? Reciprocal of this solution. 1 plus A is equal to 1 by B. 1 by B. So there is a relationship between these two terms. 1 plus A is equal to 1 by B. There is a relationship between, or you can write B is equal to 1 by 1 plus A. So there is a relationship between these two solutions. So these two solutions are not independent solution. So this is not, this solution is not another solution. So this is our only one solution. So to get another solution, we have to search for some other method. Okay, so you have to go for multipliers. Now we will find out the another independent solution. To get another solution, we have to use the multipliers. We will see how to get these multipliers. Our equation is dx by x squared minus y z is equal to dy by y squared minus z is equal to dz by z squared minus x. This is our subsidiary equation or auxiliary equation. So from this we have to use the another independent solution. Using this we have to find out the another independent solution. So for that you have to get the multipliers very easily. Y is it y plus z, and then from zx you have to use z plus x, and from that xy you have to use the multipliers x plus y. Okay, so these multipliers we have to use in this equation. So this equation becomes, each ratio will be equal to, here first term is multiplied by y plus z, both numerator as well as denominator you have to do it. Okay, and in the same way here in the second term you have to do it with x plus z plus x. Here also x plus z and z plus x, and here also x plus y, and here also x plus y. This is multiplied and you have to add simultaneously. So y plus z dx plus x plus z dy plus x plus y dz divided by y plus z into this y squared x squared minus yz plus z plus x into y squared minus zx plus x plus y into z squared minus xy. Now you have to multiply each and every term. So y into dx y dx plus z dx plus z dy, and then x dy, okay, plus x dz plus y dz. Okay, next term is y is multiplied with these two terms, yx squared minus y squared z. Y into y is y squared z, plus this z is multiplied by these two terms, z into x squared, plus into minus you have minus, and z into y z, that is y z squared. Okay, and next one is plus z y squared plus minus, plus into minus you have minus z into z squared into this x, and next term is x is multiplied by this xy squared, and plus into minus you have minus, and z into x you have z squared, x squared, x squared, and similarly x is multiplied by these two terms. So x z squared that is sorry x is z squared plus that x is in x into minus xy, so you have minus x squared y plus y into z squared minus x into y, so minus xy squared. So after that you have to cancel all the terms. Y x squared, so here where is y x squared? We have to search for y x squared. Y x squared, here minus y x squared plus y x squared get cancelled, minus y squared is z, minus y squared is z. Okay, minus y squared is z, whereas y squared is it here? Y squared is z, here plus y squared is z. Okay, and x is z squared, sorry, z x squared minus z x squared minus y z squared minus y z squared, so minus y plus y z squared and minus z squared x, here minus y z squared x, here you have z plus z squared x and then xy squared minus xy squared, so you will get the denominator will be equal to 0. Okay, so y dx plus x dy plus z dx plus y dz plus x dz plus x dy by denominator will be equal to 0. So that will be equal to here y dx plus x dy can be written as d of xy. In the same way, z dy plus y dx can be written as d of yz, and in the same way x dz plus z dx can be written as d of xz. Okay, d of xz divided by this 0. So this will be equal to each ratio, that 0 goes to 0 into each ratio, it becomes 0. So d of xy plus d of yz plus d of xz. Okay, so this integrating this, you have integration differentiation will get cancelled, so you have xy plus yz plus zx will be equal to your constant of integration. So this is our another independent solution. So there is no relationship between this solution with the first solution. So your general solution of the given Lagrange's equation is phi of u comma v, and u value is x minus y by y minus z comma, and v value is xy plus yz plus zx, that will be equal to 0. This is our required general solution. That's all for this video. If you have any doubts, please provide in the comment section. Thanks for your time and thanks for watching. Thank you.